Good evening, everyone. Hi, I'm Chris Minnick. Thank you all for coming out. We've got a great night here, and I'll get started right about now. And we're going to start out, we've got it's going to be an interesting meetup. This one is not exactly related to AI. We're going to talk about blockchain, but it's definitely very relevant for what's going on just in computing and with AI today. So I think it's going to be great. We've got Avolyn Fisher, who is an expert in this and is also very much involved with women in data, and it's going to be great. Before that, we're going to have our pizza sponsor. I want to give a big round of hand for our pizza sponsor. This is Josh from Tech Systems. Thanks for saying a word.
This is the part where I pretend I'm famous and good looking. So, my name is Josh Gurr, I work with Tech Systems. We're a privately held IT consulting firm here in the area. We're nationwide, but I focus primarily on the Sacramento region. I've been doing this about 20 years, so I continuously say I've been doing this since I had hair. I focus on application development, technical leads, solutions architects, senior level developers, and what I usually do at these events is I give what I call the monthly market update. And that is what we've been seeing lately behind the scenes. I get a ton of access to stuff you're not really going to see posted on the job sites, or it's not a common discussion out there, but we're seeing it every day on our board. So what we've been seeing is a huge influx of full stack demand. So people that have 70% back-end skill with about 30% front-end with one of the latest JavaScript frameworks. That is everywhere. It's ubiquitous. So I've been telling people, if you're interested in breaking into the industry, coming in through the JavaScript back door, so to speak, 2 years of experience is carrying the same weight as 10 years of experience. So I thought that was relevant. Another thing we're really seeing a lot of is satellite offices. eBay, Williams-Sonoma, Berkshire Hathaway, just bang, 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 down the list. They're all opening satellite divisions here in Sacramento, and a lot of them are doing it quietly. Berkshire just purchased a 70-man facility, and they're putting their first 5-man scrum team in next week. So just interesting times to see them stop trying to get people 2 or 3 days a week in the Bay and the rest remote. They're actually getting the message where they're opening satellite offices here. We're also seeing quite a bit of startups activity. J-Sales has been a huge part of that. The Hacker Lab here has been a huge part of that. But we're seeing enough of it that the talent is here, and I think these companies are trying to capitalize on it. So what I do is I don't call people about jobs, right? That's not what I'm kind of past that. I try to focus on where people are at with their career, what direction they want to head, and if I get something that lines up with that trajectory, at least I know to make them aware of it, even if they can't act on it now. And if the stars ever line up, great. But in the meantime, I can keep them posted again on what I'm seeing behind the scenes. So I refer to it as the 3 U's. If anybody's underpaid, underappreciated, or underemployed, I fix that. My cards are in the back, and I'll be here at the end if anyone knows anyone. So thank you very much.
Okay, and then I also want to thank Hacker Lab for letting us use the space. And they are going to be starting an AI boot camp, and I think we'll be hearing a little bit more about that after Avolyn's talk. Is that right? Is Brian here? Oh, you're there. You are. Do you want to say something about it right now?
I'll go at the end.
Go at the end? Okay, so stick around at the end because you want to hear about this. It sounds like it's going to be really great. And Brian drove out from Petaluma, so you have to stick around and listen to what he has to say. Without further ado, here's Avolyn Fisher.
Thank you, everyone. Okay, close programs to prevent information loss. That is never a good message. Okay, thank you for coming out today. I hope that this talk is valuable and you guys really enjoy it. Quick question, because I always like to get a feel for the audience. Who in here is here on a date tonight? Woo! Come on, don't be shy. All right, blockchain and chill. You heard it here. So if you had to rate on a scale of 1 to 3, with 1 being beginner, little to no knowledge, 2 being moderate, 3 being you're an expert, but you're trying to, be chill about it. Where would you rate yourself when it comes to blockchain? Raise your hand if you're a 1. This makes my job easier tonight. Where are you at? If you're two? Any threes out there? Okay, if I need backup, I'm gonna hold it. Did I say 1 to 10?
Oh, gotcha.
Okay. I know. My brain is a little fried. That's how hard I work every day. No. Okay. So a little bit of background. I'm originally from Iowa, and I went to Drake University, and I studied finance and marketing. I always joke with people that finance was to show I have a brain, but marketing to show I have a personality. When you say finance, people, numbers, it scares them. And then I started working at Nationwide, and then moved to Sacramento after I graduated, and went from being a commercial underwriter to an analyst on the commercial field product team, which is what I do right now. And when I started working in that job, I was hungry for more data, and I wanted to know more and get my hands on as much as I could. So I started looking at meetups and found Women in Data. So I am a co-organizer for Women in Data. We have our executive director here tonight, Sadie, right there. So feel free to check our meetups out. They're pretty fabulous. And I am about to roll into a grad school program at Villanova. So this is my last week of having a life for the next 2 years. So the insurance industry is overdue for some disruptive innovation. Every day I go to my job, and I feel fortunate to have the job I do, but I can get a little frustrated sometimes, wishing that technology was a little faster, wishing we were a little more on the cutting edge. And about 2 years ago, in February 2015, I came across blockchain while I was reading LinkedIn articles over my lunch. And it was actually an insurance article, so that's unusual. I don't typically find out about new technology from my own industry. Insurance tends to kind of lag behind, unfortunately. And I was just freaking out. I told my manager, and I'm pretty sure he thought I was like, I'd had a beer over lunch or something. And I texted my friend at Lyft, and he hadn't heard of blockchain, and he lives in San Francisco. And I'm like, wow, I know about this before he knows about it. And really ever since, I've been trying to get my hands on anything that I can when it comes to blockchain. I'm sure many of you have heard the hype, we should be taking this as seriously as the internet in the 90s, but we've still yet to see kind of what blockchain is going to do, but I don't think that is too far off. So, I'll give you a minute here to read this quote from Mark Andreessen. So really the point of blockchain is establishing trust through the internet, which we haven't had up until this point. But how did we get blockchain? So in 2008, Satoshi Nakamoto, which is a pseudonym for a person or people, published a white paper called Bitcoin. In his paper, he argued that he had solved the issue of double spend for digital currency via a distributed database that combined cryptography, game theory, and computer science. So when this happened, I use this picture here. It's kind of like we got Bitcoin dropped on our doorstep like a baby in the middle of the night. We don't know exactly who created Bitcoin. And really, it's not Bitcoin that is the most exciting piece. It's the blockchain behind the Bitcoin that is so powerful. And I personally believe that if we knew who created blockchain, this person would have a Nobel Prize, an economic prize. And so maybe they're trying to lay low. They don't want the notoriety, or maybe they don't want to be a target, depending on what industries get disrupted. How many of you have seen this graphic up here before? Okay, a few of you. This is like the quintessential blockchain graphic. I feel like if blockchain were a tattoo. I had a college professor for philosophy that had a synapse tattoo on his arm, the structure that permits a neuron to pass chemicals to one another. And some someday that's going to be me. I'm going to have like a blockchain tattoo on my arm. No. So you can see on the left, you have your typical centralized database. You want to think of your home, although I'm sure most people here have theirs backed up on multiple sources, but think of your home computer, having that central server and that central connection. And then you've got a decentralized database. A lot of large companies do this. They'll have their servers spread across the US in case a tornado rips through one of them, they still can be up and running. But with distributed, which is the blockchain, really anyone running the blockchain is going to have a copy of this database. And therefore, it becomes the most secure database that we really have ever had. In order to hack it or tamper with it, you would need to disrupt every instance of the blockchain, which is impossible. So the blockchain is spread over millions of computers all over the world, and there's no central point of failure. It creates trust where there is none, because everyone has a copy. If you wanted to lie and double spend Bitcoin, you can't do that because everyone else has a copy and knows that that's a lie. It becomes democratized and uncensored. It's immutable, which just means that you cannot be changed once committed to the ledger. However, the network must come to consensus to update the blockchain ledger using an algorithm. And then it uses cryptographic identity for authentication, sort of like a password, kind of like a secret identity. And I'll break this down in a few more analogies. If you're very new to blockchain and you're thinking it's not clicking or it's confusing, that's, from what I've heard, pretty normal. I spent the first year reading about blockchain, just going over the basics, because my brain just couldn't wrap around what the heck was going on. So how does it do this though? How is the blockchain actually operating? So it uses some common consensus algorithms, proof of work, proof of stake, and the practical Byzantine fault tolerance. So proof of work is used with Bitcoin as well as Ethereum, and it requires that in order for a block to be accepted, miners must complete a proof of work. And this is the mining that you may have heard of that goes on with the Bitcoin and Ethereum. And the proof of stake, this is a little bit different, where the creator of a new block is chosen in a deterministic way depending on its wealth, or otherwise known as its stake. So Ethereum has released an implementation plan to be moving to the proof of stake. The benefit, because you're not having everyone compete, it really reduces your computing power considerably when the system's choosing who's going to be the main miner. And then for PBFT, this is used by blockchains such as Hyperledger, Stellar, and Ripple. This relies on generals who review messages and kind of agree on the best approach. These are the three main consensus algorithms. So what are the miners doing? Let's talk about them because that's still the main algorithm. And this is going to be hard to read, so I can go ahead and read that. But essentially, the blocks are produced in intervals, forming a chain of verifiable blocks that contain the transaction history, providing data a form that cannot be altered without redoing the work of the previous block or confirmations. The end result is a single immutable journal of transactions grouped through time-ordered blocks distributed and written by all of the nodes on the network. So, to put it in real simple terms, imagine you were trying to solve a Rubik's Cube, and you had a room of people trying to solve the cube, and one person finally figures out how to solve the Rubik's Cube. They're going to get the award, the miner, they're going to get the Bitcoin, and then they're going to show the solution to the rest of the miners and have them verify that this is the solution. So this is essentially what's going on for the blockchain. Eventually one player will end up with a solved cube and the prize, and then the next round begins. So there is a difference between public and private blockchains. Not all blockchains are equal in that sense, and there's trade-offs. So for public, it's trustless, and private, you would want to have trust to some extent because your information is not going to be completely private. So for corporations, they're more likely to use a private blockchain rather than a public blockchain. And it also comes down to performance versus security. So public is going to run a little bit slower than a private blockchain as well. So let's dive into Bitcoin and Ethereum, since they're kind of the most common blockchains we hear about today. Because Bitcoin is so simple, this is why you sometimes hear people say that if Bitcoin can't work, then other forms of blockchain are not going to work either. And so, in my opinion, Bitcoin is the least exciting application of blockchain. But again, it's a good testing ground. If this fails, then other blockchains are going to be doomed. It faces some scaling issues. Although the market cap is in the tens of millions, with millions of users, it can only run 7 transactions per second, compared to Visa that can do thousands of transactions. And you may have heard of some history of hacking with Bitcoin, but the hacking actually occurred on the exchanges like Bitfinex, and so because the Bitcoin is centralized, the blockchain itself wasn't what got hacked. It's important to remember that if you have currencies, you want to remove them from the exchanges because the exchanges are not going to be as secure as the blockchain itself. But overall, the blockchain for Bitcoin is very secure. The block creation time is about 10 minutes, which is long, you'll see, compared to Ethereum. And it uses simple stack-based language. So looking at Ethereum in contrast, this is a decentralized platform designed to run smart contracts. So think of it as everyone is sharing this computer to run programs on and conduct transactions, and Ether is the native asset. Instead of getting a Bitcoin, you would get an Ether as a miner. And the real big difference and what makes Ethereum so earth-shattering is that it's Turing complete using scripting language. So you can write programs to be executed on Ethereum with the full expressive power of any modern programming language. That's not the case for Bitcoin. So theoretically, you could run entire programs and software on Ethereum, and really has so much more potential. And the other benefit is the block creation time is 12 seconds instead of 10 minutes. So it's a heck of a lot faster. It's very exciting. If you actually go to the Ethereum website, you can download Ethereum. And I was all excited to get mining, but my computer is not powerful enough because you need like a graphics card, and you're going to have an increase in your utilities, and you might make $15 a month. And so it's kind of funny. You go on there and they're like, create your own cryptocurrency and create your own organization, your own government. And it was my mind was like, what are people doing on here? So yeah, it's worth checking out if you're wanting to take a look. So let's talk a little bit more about this smart contract and what that entails. This smart contract is what I first heard about with blockchain, since I work in insurance, and got me excited. But the smart contract is what works through Ethereum, and it runs like an autonomous agent living inside of the network, and it reacts to the external world when poked by transactions. So a contract is a written or spoken agreement intended to be enforceable by law. A smart contract is code that facilitates, verifies, or enforces the negotiation or execution of a digital contract. A trusted entity must run this code. So this is really the foundation of Ethereum and kind of what the programs are running on. Let's get into the fun here and talk about some more use cases. So when I first started reading about blockchain, I heard about the idea that you could create digital identities. Think of birth certificates as one example. So right now in the US, over 6,500 different entities issue birth certificates using over 14,000 different forms of birth certificates. And this is a big problem because these documents can be used for passports, driver's license. You can do pretty much any kind of crime with these birth certificates and creating fake identities. So this is kind of the no-brainer, essential idea here. Some other examples are property titles, car titles, government benefits, death certificates. There's even an idea that one day you could use the blockchain for a smart grid. You know, if you have some solar panels on your house and you wanted to sell your energy to your neighbor. So transactive grid and grid singularity are companies currently looking at a blockchain energy grid. And then also just think about, you know, free trade and the issue of slave labor and where your supply chain comes from. So Everledger is a global digital registry for diamonds powered by the blockchain, and they use more than 40 features, including color and clarity, to create diamond IDs. And they've digitized more than 1 million diamonds and partnered with firms like Barclays. And that stuff I just think is so cool, that we can use blockchain to verify diamonds and verify where they came from and the quality. We can verify prescription drugs. There's a lot of fraud in the prescription drug market. Countries are using it for their voting system. So right now, the Liberal Alliance in 2014, it's a political party in Denmark, became the first organization to use blockchain to vote. And think about how easy it could be if you could use the blockchain to vote from your home computer. You wouldn't have to leave, and you would know that it's not it's tamper-proof and it couldn't be hacked. And I think that voter turnout would really increase if it was that simple and you knew that your vote was going to get counted. And so that's just a few other basic use cases. Another big one that really blew my mind, does anyone remember last October, I believe, when there was the DDoS attack that took down Twitter and Reddit for like 12 hours, and I was freaking out. I thought my internet wasn't working, and then I read it was a bigger issue, but it was harder to read about that because my Twitter wasn't working, so I couldn't read about it on Twitter. But these attacks are becoming a big deal. So far in 2017, 86 countries were hit by a DDoS attack in the second quarter of 2017, up from 72 in the first quarter. And the longest attack, I didn't snag the country name or where it occurred, but it sustained for 11 days. If I lost Twitter for 11 days, I think, I don't know, it's scary stuff, and it really is a huge potential terrorist risk, and really can shut down our economy if we were to have a successful DDoS attack that shut us down for 11 days. And with the power of blockchain, and you could run your servers through this and really protect them from these types of attacks. Let's talk about connected devices. So the figures on when it comes to connected devices are kind of all over the board. You know, some say there's going to be 40 billion by 2020, and some are more like, 20 billion. But either way, I think we all know that we have more and more connected devices than we've ever had before. And there's very little that's keeping these things secure. You think about a Nest. I don't know how many of you have a Nest in your house, but they've found that you can successfully hack a Nest with ransomware, so they could, tell you that I'm not going to turn on your AC until you give me $3,000, and that would be my worst nightmare. And so these devices really need to be secure, especially when you think about vehicles. And the blockchain is a potential solution for that, to add security to those connected devices. Of course, all of this is happening on the dark web. And, there's a lot of talk about the dark web, like it's this wild west of crime, and drugs are bought and sold, and it's just not the most pretty picture when people describe the dark web. So I wanted to kind of take a moment to add some clarification. So blockchain is traceable. There's anonymity to it, and if you're good at what you're doing, you can hide your identity. But in the sense that if your identity gets revealed as you're pushing drugs across the blockchain, selling Bitcoin, the FBI is going to find you, and they're going to be able to prosecute you. So if you're thinking that's like your free route to buy some drugs, I would do it with caution. I don't know if any of you have heard of the Silk Road. So it was a Bitcoin market facilitating the sale of $1 billion in illegal drugs. And Ross Ulbricht, who created the Silk Road, was sentenced to life in prison in February of 2015. There have been other people. There was a Czech national who was seized after being suspected of laundering $40 million in stolen Bitcoins. There's been a lot of prosecutions based on crime that has happened in the dark web. So even though it sounds like the Wild West, it's still not your free reign to just go be a crazy criminal, unless that's just the thrill. No. So here's a diagram I kind of created, and essentially what happens is you have a seller within the blockchain